Yo, yo, yo. What is going on? What is going on? What is up, my friends, enemies, pals, acquaintances, new people, old people, middle aged people, everyone? What is everyone up to? Today we will be streaming, but only after I've poured myself a cup of tea. Good stuff, good stuff. Luckily, I can broadcast from my living room and my kitchen where I have my tea kettle. So this is all fun. Now I don't have to stop talking to go get a beverage. Wow, chat's blowing up, or it isn't. I can't see because I'm across my entire condominium. But it's stuff is going on today. It is Friday, so this is like variety stream day, and I wasn't able to get a partner for the resume review. So today, what we will be doing is writing a Zed plugin. Zed is a newly extensible text editor written in Rust by the Zed development team, the same brains that brought you Sublime Text as well as the Treesitter protocol. So all that stuff is integrated. It's collaboration first, whether you're collaborating with a robot or a person. Zed, it is a great editor. And by great editor, I mean it's fine. It's no NeoVim, but not everything can be NeoVim. So yeah, without further ado, let's just jump right into it. I have no idea how to write a Zed plugin, but we shall see. Also, I got to get some music playing, but I'll get the music playing at some point. Let me post this. Make sure I'm live streaming properly. What's going on Twitch? Let me get the music playing real quick. I'll switch my screen. Hello, friends. So we are going to go to storyblocks.com and oh no, for some reason my levels aren't where I want them. Levels. No, I just need to yell more. Let's go to music. Let's look up Lofi. Let's hit the search button. And we'll go with most downloaded. Most downloaded today, friends. Relaxing Lo-Fi Chill by Sunday. It's too loud as always. Let me bring this back down to a reasonable volume. And today we'll be learning how to write a Zed plugin. Let's go. Turn up. Is this thing louder than I am? It might be. Pretty close. There we go. Let me turn this down a little bit more. And then turn this thing up to where I want it. Hell yeah, brother. So I think it's only natural to write a Zed plugin in Zed. I think that makes a lot of sense. Let me tweak these levels a little bit more. There we go. So let's go open Zed. I wonder if there's an update for Zed. I should probably download the newest update. Maybe I should be on a developer version. Whatever, I don't really care. So we'll do a new. That's not what I wanted. Zed settings. How do I make a new project? New window, open recent, close editor. Oh, that's not what I wanted. Edit. Where do I find a new project? Where the hell is a new new project? All right, so I clearly don't know what I'm doing here. Can I like close the project? Can I just go away? Go away, pie. Remove file from project. You know what, I'm just gonna quit Zed. I'm just gonna make a project in the command line. That's some other nonsense from another thing I was working on. Make cd source github.com npmail/Zed plugin. Oh, whoops. Make dear source github npmail Zed plugin cd that, and then we will open up Zed. Where's Zed? Who's Zed? Zed's dead, baby. All right, so now we need to go Zed file open, and then we want to open up none of this. We want source GitHub Zed plugin open. There we go, and we can just close this window. So now, here we are. So I have Z open. Now let's throw open good old F-Ray folks, and then throw down how to make a Z plugin. Z Industries / extensions. Z extensions. This is a central repository containing extensions available for Z. See authoring extensions.ind for how to author your own extension and get it added to the extension registry. Fantastic. Looking to write your own extension for Z? Yes, you've come to the right place. Fantastic. I didn't bring my glasses over here. I need those. Where the hell are my glasses? I swear I do this every time. Oh, here they are. Hopefully in their case. And yes. Don't want my eyes to start hurting. That would be bad. Also, my camera's tilted a little bit down. There we are. Hello, another viewer. Welcome. I'm working on making a Z program. Extension capabilities. They're capable of extending Z in the following ways. Grammars, don't care. Languages, don't care. Themes, don't care. These are the only options. These are my options for stuff. I was hoping I could do more. This is very disappointing. Z extension is a Git repository that contains an extension.toml. ID, name, version, schema version, authors, description. These are really the only ways to do Z extensions. I gotta be honest, I thought there was more. Well, this is simply disappointing. I don't know what to do now. My one idea for what I was going to do for the stream is apparently not possible. Now I would do an extension for VS Code, but there's already way too many VS Code extensions out there. And most of them are crap, so I won't be able to change the average quality of extension. Let's take a look at what these are, though. So we got some themes. Dark theme based on Tokyo Night. Well, that's fun. Tokyo Night. So that exists? Let's see. What's the... plugin? Z plugin. How do we... Okay, no, that's not what I want. Theme. Select theme. What? Tokyo... This is really neat that it, like, switches as you're going through the themes. But let's go. Select theme. They got a bunch of them. Solarized. Yikes. Rose Pine. Yikes. Select theme. Andromeda. I like the Andromeda theme. How do you install this bad boy? Box integrated terminal, themes, Vim mode, a whole lot more, breadcrumbs. So anyway, this is totally useless. I thought I was going to write a neat theme, but it doesn't quite support good, or not a neat theme, a good thing, but it doesn't support good plugins, which is a darn shame. So I don't know what to do now. About, revision. Oh, they have jobs. Rust application developer. Well, that's fun. Main life kit. Well, that's fun. Love to see that. Whoa, Nate Codes. Thanks for the raid.
Nate_codes raided my stream with 9 viewers.
I appreciate it. Now, here's the problem, Nate Codes viewers. Oh, hello, Bumpy Lumps. Thank you for the follow. Here's the problem.
Bumpy_lumps is now following.
Finished a project yesterday, and today I'm trying to do something else. I wanted to make a Z extension. However, I discovered that the only Z extensions you can do are language support and color schemes, and I am not much for color schemes, and frankly, all the languages I want are already supported. So I'm left with nothing to do. So if one of you kind people could suggest something silly that I can do, since I finished the last project I was working on, that would be fantastic. Maybe I could just show you the project I was working on. That would be fun, right? Anyone? No one? Whatever. Now the last thing I was working on. Let's get on to it. HTMX Pong. I've made this this nice little video game. Localhost 8080. Also, tell me if there's anything wrong with the music at all. Maybe a little loud. So it's Pong, but it's written in HTMX. So in one-player mode, you can play Pong, which isn't that impressive. Anyone can build a Pong game, but I bet you've never seen a Pong game that absolutely slams the network like this one does, because every single frame is a network request to the back end, and it's written using HTMX. The only JavaScript here is HTMX, and honestly, the only dependency is HTMX, whatever's already built into the browser, and then Go. So this is pretty fun. And you're saying, but Nate, what use is this? This seems totally useless. And I agree, it is totally useless, except for oh, it's not big conf, it's con. It's totally useless, except for the fact that I will be presenting about it at Big Sky DevCon, not Ryan Florence, but me here, Nathaniel Mail. That's going to be me. I'll be presenting at Big Sky DevCon about the wonders of HTMX, hypermedia, and building silly things in silly ways. So that's fun. So you know, Big Sky DevCon. Go there. I'll be giving a talk there with my friend Diesel, aka John Michael Hartway. It's gonna be a good time. Check out BigSkyDevCon.com to find out more. I don't think they put my face on here yet. That's disappointing. Maybe they won't ever put my face on here. Maybe I'm just too useless. So they put Ryan Florence on here. He wasn't on here earlier. They must have just completely skipped me. That's disappointing. Anyway, so yeah, check that out. It's hosted by it's gonna be hosted by the Primeagen. The guy who wrote HTMX is the guy who runs the conference. It's a good time. But anyway, back to the problem at hand. I came on here very hyped up to write an extension for Zed. Someone gave me a very good idea, and then I discovered that it's really just themes and languages right now. So I am at a loss as to what to do. And since Nate Codes sent over a raiding party, I feel like I'd be not giving you the proper experience if I just went around and did almost nothing. So I gotta figure out what to do here. Now I have built some silly video games. Here, let's see, I think it's Bunveet to run this thing. Localhost 5173. Yeah, so this is a Flappy Bird game that I wrote. That's, I mean, kind of dog shit. This is one of them I did on a previous Friday stream. I got pretty much all of this done in 1 2-hour session, which I thought was pretty impressive, given that I never knew anything about Canvas before. But damn, I lost. And it keeps telling me I lost, and it freaks out a little bit. It's not perfect. Anyway, I don't know what else to do. I've already built stupid games in the browser. I could build a smart game in the browser. I could do some brain dead React content where I just react to stuff. I can do brain dead React content where I react to React articles. I'm not going to do any of that. I hate reacting to things. Anyway, What else? What else is out here? I don't know. Leak code. I can do leak code. Does anybody want to watch me do leak code? I haven't done any leak codes in a while. Oh, did they change the UI? They must have changed the leak code UI. I don't know how to get in here. Sign in. Let me use this. Leak coded in with good old GitHub. So I mean, let me know if you think I should just write some leak code, because I suppose I could do that. Freedom Trail. Hard. Hell yeah. The video game Fallout 4, the quest Road to Freedom requires players to reach a metal dial called the Freedom Trail ring and use the dial to spell a specific keyword to open the door. Given a string ring that represents the code engraved on the outer ring and another string key that represents the keyword needed to be spelled, turn the minimum number of steps to spell all the characters in the keyword. Initially, your character of the ring is aligned to 12 o'clock direction. You can spell all the characters in key one by one by, I gotta run to chill with the fam a bit and touch grass, but we'll keep the lurk up for you, friend. Keep on crushing it. Wild to see what you're doing with HTMX. Thank you, Nate Codes. I appreciate it. Also, I appreciate the raid. I'll have to get you back one of these days. But you're gonna have to start streaming around 10 p.m. because that's... Anyway, the stage rotating, let's see. You line to the 12 o'clock direction, and then by pressing the center button at that stage of rotating the ring to the spell key character, key of I. You can rotate the rings clockwise or anti-clockwise by one place, which counts as one step. The final purpose of the rotation is to align one of the ring characters at the 12 o'clock direction, where this character must equal key of I. If the character key of I has been aligned at the 12 o'clock direction, press the counter button to spell, which also counts as one step. After the pressing, you could begin to spell the next character in the next key stage. Otherwise, you have finished all the spelling. Okay. So the ring says G-O-D-D-I-N-G. The key is G-D. So you want to find the first thing. Usually the morning hours, but I'll make it happen one of these days. All right, good stuff. One of these days we ought to co-stream. We can get working on some stuff together. I think it'd be a good time, Nate. Anyway, for the first character G, since it's already in place, we just need one step to spell this character. Oh, I see. So it's already there. Rotate the ring. Godding anti-clockwise by 2 steps to make it da-ding-go. Also, we need one more step for spelling, so the final output is 4. Oh, well, definitely get a collab on the books. Hell yeah, brother. Constraints, key, ring.length, key.length, whatever ring and key consists of only lowercase English letters. It's guaranteed that key could always be spelled by rotating the ring. So once you rotate the ring, do you have to also... No, you just press the button and then you have to rotate it again from there. So, let's see, what language should I use? I kind of want to use Go so I can blow your socks off with how quickly and effectively I solve this problem. So since this thing is a ring, I kind of want to just, let's see. Does this thing have a Vim mode? Am I in Vim mode? Where's the Vim mode? Code format, submission notes, retrieve last, reset to last. Is there like a settings button? Settings, code editor. Vim mode? No Vim mode. Shortcuts? Vim mode. Vim mode. Advanced, Vim mode. Dynamic layout? Vim mode. Code editor, Vim mode. Nah, that's not gonna work out. So basically what we have is, so we'll have I can't use Vim. We'll say current position : equals 0. So this will be on the ring. So the current position will start at 0, and then we will move it as we go forward and back around the things. Then what we'll do is for underscore, comma, L for letter, : range string, which of course we will need to figure out. So for underscore, comma, letter, : range string, what we'll need to do is we will need to get the ring to rotate to that position, which means that we need to find which index in that string it is. But instead of finding the index, we need to find the difference between the index and our current index, including going backwards from 0. So I think I'm just going to do a separate function for that. I think that makes a lot of sense. So for each letter in that target string, what we need to do is we need to go backwards and forwards until we find that letter, and then say where the current position is, and then keep doing that. So let's just do a little helper function called I don't know. Let's see. I need Vim mode. This is the problem. I'm just gonna copy this. I'm just gonna copy this. Is there not a copy command? Command Z. How do I copy this thing? You know what? Whatever. We'll just put this over here, and we will just do our writing over here. cd ... We'll just make your decoder ring thing, and then we'll go mod init decoder ring thing vi main.go package main func main, and then we'll say func find rotate steps ring string key string, and then what does this return? A number, right? The lowest number of turns. So this will return an int. Let me make this bigger so you can see it. Oh, let me turn off the thing that makes it so that only people who are following can comment, because I want you guys to comment if you have interesting things to say. Followers only chat is off. All right, now viewers, I got to see you sounding off. I turned off followers only chat. This is a vulnerable moment for me. You know, I mean, I can't force people to follow just so they have a voice. I mean, this is a bit of a trust fall for you guys, or for me, whatever. So let the comments commence. And feel free to call me dumb or whatever. There's no code of conduct in this room. You can say whatever you want as long as it's not going to break the rules of Twitch. You can, you know, bully me, whatever. I don't care. I have a thick skin. Smash cut to 4 minutes from now. I'm just crying because of how rude you guys are being. So anyway, so we'll say we'll just make a struct or a type decoder ring struct. So let's just model the problem a little bit. So then we have the ring contents, the string, and then we have the current position, which is a string. And then on the decoder ring, we'll have a func with a decoder ring. And then this will be func decoder ring. This one will be for rotate step, and then it will take an int, and this can be positive or negative. And then we'll just, I mean, we could do a slight bit of math to get the overflow going, but like, frankly, I don't really, actually, no, I will do that. So we'll just say if len d.ring contents, we'll say if steps is greater than, say math.abs, if the amount of steps you want to move is greater than the length of the entire contents of the ring, then there's a problem that's occurred. Ring not big enough to, let's see. If there's more steps than the size of the ring, then that's going to be a problem. So we'll panic there. Attempting to turn the ring all the way around, which is a waste of everyone's time. Need to import math, code action, import math. Oh, and this is mad at me. Steps is int, len, d.ring contents. What? Cannot use steps int as float64 value in math.abs. Is there not an absolute? Integers are assigned by default, right? Int64. Yeah, fair enough. Steps int 60, whoops, int 64, and then we'll say int 64 that, what? I must have misread it. Oh, it has to be float 64? Is there not an int 64 absolute? 64, Golang. Well, this is very silly. All right, so I guess we'll get we'll make our own absolute value function. Func abs I int if I is less than 0, return I times -1. All right, not sure why we have to do that. It returns an int. Return I. There we go. So we don't need to use math.abs. We'll just use our own ABS. And then, of course, I need to make this not int64 anymore. Make this not int64 anymore. There we go. So if the absolute value of the steps is greater than the ring contents, we're going to panic. And then what we'll do is we'll say if ABS, let's see, if we say if current position plus steps is greater than or equal to the length of the ring contents, then we need to loop around, right? So it's an array of one length, then the only index is 0. So if it's an array of n length, then the last index is 1 minus the length. So if it's equal to or greater than, then that's too much, right? So if we overshoot it, yeah, so this will check to see if we overshoot the ring. If we overshoot the last index of the string, we have to loop back around. So then we'll say, oh, we need to be counting the steps we've taken. Steps taken, int. Aha, we're not using math. Oh, current position should be an int. I'm discovering live right now that I'm not very good at explaining what I'm doing. Anyway, so you take the current position plus the steps. If it's greater than the amount of letters on the ring, then that means what we need to do is say d dot current position equals so we set the current position equal to whatever's left after you subtract the length of the ring contents from the well, however much is left from the current position. Man, I'm not good at algorithms. Anyway, so we'll say len d dot ring I'm just gonna make this real easy. We're just gonna say, actually, never mind. D.ring contents. Let's see. I feel very silly because I don't know how to think algorithmically as much as I should. I'm used to just taping different, what's it called, APIs together as my job, which, spoiler alert, if you're a new programmer, 90% of your job will be taping various APIs together. So if you're not so good at algorithms, it'll be okay. Not Notepad, I want an online Sketchpad. Here we go. Pen. This is not big enough. How do I make it? There we go. Oh, this is, they really try to artistic this thing so that if you move too fast, it screws it up. A, G, Q, P, R, L, right? So if we are here and something says to go 1, 2, 3, 4 ahead, first of all, it's the same as just going 2 behind, but so what we need to do is take the length and then subtract the current index, and then that'll give us these 2. So then what we do is the index is going to be I always feel like an idiot when I'm doing this stuff. If we go 1, 2, 3, 4, 5 ahead, then that means we use up 3 here, go to the end, and go 2 more. I don't want to do this with a loop is the problem. I just want to do this with subtraction. So what I do is I just take the length of the thing, minus this, subtract that, and then the new index is the result. Duh. And I just said it, now I've already forgotten it. So we'll say new position equals length of the ring contents sorry, it's d dot current position plus the length of the steps plus steps minus d or the length of the ring contents. And that will be the new position. And then we'll say d dot current position equals that. And then we have to increment our steps. D dot steps taken equals. Now I'm thinking we're going to use this this rotate thing, trying to find the minimum. So I'm not going to actually lock in this action. What we'll do is we'll make it return the number of steps it takes. Maybe I won't. Oh, of course this thing's taking a pointer, because it would be ineffectual otherwise. So then for negative, we'll say if d dot current position plus plus steps is less than or equal to 0, Troll Patrol. What's going on in Irish Red Ales? If you're wondering, I decided that the plugins you can make in Zed are too restrictive. There's really only like 2 types you can make. So I decided to just go ahead and do a LeetCode. So this is a decoder ring thing where I have to figure out the lowest number of steps to get to a specific thing. It's a LeetCode hard, which isn't actually that difficult. Oh, this is fun. Rex has thrown up the facnate.nautilusshell.nl. So if you don't like what you're seeing, you can just give a "fac you," which is very offensive to me, but you know. So it's been hit 19,407,558 times, which again, very rude. Now, few tens of thousands of these were due to me writing a script to hit it a bunch of times to see if I could take it down. But this FactNate website, very resilient. I couldn't take it down. Didn't try very hard, but still. Anyway. So if it's less than 0, what we need to do is we need to say that the current position is equal to, let's see, so we take the steps So given the steps are negative at this point, what we do is we just say steps plus, let's see, so you add on the current position to the steps to get it to 0. And then if it's still negative, then you go that far from the end. Steps plus current position. So we'll say remainder steps colon equals steps plus current position. Oh, and now it's all mad at me. And then you go remainder steps from the end of the ring contents. So you say d dot current position equals len d dot ring contents. So you go to the end minus that many steps, plus steps. Remainder steps. And then let's just add in a main function and test this bad boy out. Decoder ring colon equals decoder ring, which is a struct, which we will fill in here. Fill that bad boy in. Ring contents will be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Current position 0, steps taken 0. So then what we'll do is we will do decoder ring dot rotate step, and then we need to go, let's try -2. Whoops, -2, which should put us at, oh. And then we will we'll just fmt.println Rust, bro, you're not streaming only audio. Oh no. Didn't mean to do that. Must have hit a button. Oh, I absolutely hit a button. I see. One of my errant cables clicked my one of my errant cables clicked my my Stream Deck. Didn't mean to do that. Well, you did do it. Yeah, I recognize that. So what we'll do is we'll print out decoder ring dot ring contents at index current position. So we'll run this and see what happens. 111. Let's turn this into a string so I know what it actually says. Oh, so that worked. So then we'll do one at, we'll just make it shorter. 0, 1, 2. We'll start at 2, and then we'll make 3 steps. So we start at 0, 1, 2, and do 3 steps. We'll go 1, 2, 3, so we should get a B. And we did, so that works now, which is fantastic. So we'll do func D pointer to decoder ring, and then we'll say get letter. And I will take nothing and return a string, which will just contain the single letter. Actually, no, I think it'll return a rune. Yeah. So what we'll do is we'll say d dot current position, and we want d dot ring contents at the index of current position. Also, before any in the comments say I'm doing this in a very simplistic way, yes. Glad we got that figured out. Value of byte as rune and return. Ring contents is a string. Oh, maybe I'll just make it a string. Oh, of course, because it has to be. I'm not asking for it as a rune. Anyway, that didn't do anything. So we have that. So to find the rotate steps, we need to try going forward and backwards to see what the minimum number of rotations to do each thing is. But what is interesting is to find the minimum. Oh, that's why this is a LeetCode hard problem. To find the minimum, it could be if you start at like, let's see, I'm trying to think of what word. If the word is like, say, God, and you start here and you go 1 to get to a G, and then you go 2 more to get to a D, and then 1 more to get to a, 2 more to get to an O, and then 1 more to get to a D. Or if you start here and you go 1 and then 2 more, I suppose that doesn't make a difference. Anyway, I can see how this is difficult. This could be like a thing where you have to try, well, I guess we could do a really horrific algorithmic complexity, try checking every single combination and go from there. But that might be difficult. Let me read through this thing this bad boy again just to make sure. The permissible excuse for non-gamers to bluntly ignore this condition. Back-to-back hard. Yeah, there we go. Not so difficult hard. Simply determine the lowest cost to jump from one position to another. Yeah, this is all fun. Anyway. Maybe it isn't actually that difficult. You just have to find the lowest on each direction. I don't know. I suppose we might get slapped when we try submitting, but we'll see. So what we say. So when we get a ring in the final thing here, we'll say what will we do? We'll say decoder ring. We'll call it R. Colon equals decoder ring, fill in this struct with a code action, whoops. Ring contents will be ring, current position 0, steps taken will be 0. Then what we'll do is we'll say for underscore comma K, colon equals range key. Then what we'll do is we'll go let's see, for underscore comma, for I colon equals range len ring divided by 2, because we're going to go both directions. Divided by 2 plus 1. Nope. Divided by 2 plus 1. So then what we'll do is we'll say, well, we probably need to put in a find letter function in here. Func d decoder ring, oops, find letter target string. So we need to find a letter. So to do that, we'll involve going backwards and forwards. Through each thing, and then we will return the rotation steps. And then, so of course, we'll say if get letter equals target, then we just return 0 because that's the number of rotation steps. D dot get letter return use 0, return the if the letter on the ring we're already at is the target, we will return 0 because we're already there. Then otherwise what we'll do is we'll go through positive and negative all the way through, and it says it's guaranteed the letter is going to be in there, so I'm not going to worry about it too much. So we'll just say for I colon equals 0, I is less than len d dot ring contents. I plus plus. Then we'll just say check letter at I. Prime never articulates for his loops. Okay. I'm not Prime, so I'm gonna live my life. And then we'll also honestly, we can make this get letter. Get letter should take an int, I think. Yeah, you know what? I can do this better. So instead of get letter, we'll change this to we'll just change the definition of get letter. Get letter at I takes in ring turns int, and then instead of doing that, we will say well, I already wrote this function up here. I'm just going to use this. Temp colon equals decoder ring code action, fill that bad boy in. Ring contents is going to be d dot ring contents. Current position is d dot current position, and steps taken is going to be d dot steps taken. And then what we'll do is we'll just say temp.ring contents and temp.current position, and then we'll say temp.rotate step ring turns. Now this will be crazy on the memory, but we can go and fix that later once we get it solved. I always find myself doing things really poorly at the beginning, and then you fix it later and it's as though a bad thing never happened. Let's say d dot get letter at I, and we'll say if d dot get letter at I is equal to target return I, and then we'll say else if d dot get letter at negative I is equal to target then we will return negative I. And then otherwise, what we'll do if we get all the way through, we'll panic, tried all the positions on the ring and failed. So that's fun. So then for each one, what we'll do is we will say r dot find letter, and then it will be string k, and I will say turns, and then what we'll do is we'll take total steps equals 0, and then we'll say total steps equals plus equals turns plus 1 to lock it in. And then what we'll do is we'll our main function, we'll give it a shot. And then it will, let's see, find rotate steps. So then we will return total steps. That looks fun. So I'm returning total steps. And then in main, what we'll do is we will do find rotate steps. With a string and a key, we'll just steal these from here and see if they work. Ring is gotting, key is gotting. That's not very good. And we should get 13. Oh. No, screwed that up. Ring thing main 46. So we were rotating steps and we had a problem. Find letter. Did I use the wrong function in here? I want the find letter. Yeah, find letter, string k. So we'll just add some debugging in here. Find letter, fmt.println, finding letter, %s. Oh, we need printf instead. Finding letter, %s, new line, comma, target. Let's see how we were trying to call that. Finding letter G. So it really failed immediately. So let's see. So it came down from 47 is where it called, and then it went to 31. So 47, we already went to 31. So if d.getLetter I equals target. So it's in 47. So it's trying to rotate step, and it broke, which is very strange because rotating step at 0 should have not done anything. I think I have a less than or equal to 0 when I need just an equal 0. No, I just need a less than 0, because 0 is fine. There we go. So I got GODDING, -12. Ah, that's right. So when you give the steps, it gives the direction of the steps and the thing, when in reality, I just need the absolute value of turns. $26, so it double did everything. Maybe I'm not counting something right. Let's see. First character G, whatever. One more step for spelling. Let's see. Rotate the ring clockwise and anti-clockwise by 1 step. Select one of Ring's characters at the 12 o'clock direction, where this character must equal key I. Press the center button to spell, which also counts as 1 step. After pressing, you can begin to spell the next character in a key stage. Otherwise, you have finished all the spelling. So each one of these steps should just be 1. So you should 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6 inserts. So for each key, it should just work out. What's wrong with this? So the absolute value of the turns plus 1. So in the turns is going to be to find each letter. So we check the letter, we check the negative letter for each I is less than that, I plus plus. Also, I could do I, comma, underscore, colon equals range, ring, contents. Since we're dealing with the, oops, there we go. Oh. There we go. This probably doesn't fix it. Yeah, and this is mad at me. There we go. So it's 26. So let's just have it print out what the value is before it adds it. fmt.printf about to add %d to total, and then %d is going to be turns. Oh, so it went back. So it's finding the negative numbers. -6. Let's see. It finds 0. About to add 0, and then it finds. Oh, I need to do a \n. So it finds the G, 0, and then it adds -6. 1, 2, 3, 4, 5, 6. When in reality, it should just add +1. So why isn't my find letter working? So it should try d.getLetter at I should equal the target. So we'll just check getLetter. We'll say starting at %s, do fmt.printf starting at %s or %d. Checking %d turns for letter %s. And then the first D is going to be D dot ring contents. No, starting at D dot current position, checking D turns, that's ring turns. I don't want this. I actually need this up here. We'll say finding letter. Printf about to return %d I, and then we'll do the same thing here. So it should be checking forward and backwards at the same time, giving a slight preference to forward. But for some reason, it's not doing that. And I don't know why. What is that about? Also, I already knew it was about to return. I already have a printf for that. So let's see, is there something wrong with get letter here? And so we copy it into this temp, and then we rotate it that number of turns. If the number of steps is greater than the content, then we panic, but we haven't gotten that, so that doesn't matter. Oh, I need a new line. 0, 1, -1, 2, -2, 3, -3. About to add -3. 0, 0, 1, -1, 2, -2, -2. Huh. Oh, you know what? Should go 0, and then 1, 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 and then 1. So 0, 1, 2, let's see. This is not the one I wanted to get rid of. So it goes 0, -6, GODD. So that should be going -4. Is it 1, 2, 3, 4? So it's working only in negative and it's not updating it. Which means I've made a mistake here in find rotate steps. So I find the letter, but I don't rotate it that many. So that makes sense. Then what I'll say is r dot rotate step turns. So that will solve one problem. And cause another. So now it wants -6, -5, -6, -6. So now it's just going backwards every time, but it is keeping track. So this way it goes -6 to find, so it goes 0 to the first one, and then it goes 1, 2, 3, 4, 5, 6 to find the second one. And then to find the D, it goes 1, 2, 3, 4, 5, and then it adds 0, And then it goes 1, 2, 3, 4, 5, 6 to find the I, and then it goes 1, 2, 3, 4, 5, 6 to find the N, and then 6 to find the G. 2, 3, 4, 5, 6. So at least we have that done. But why isn't it checking the other direction when we're checking this? So we'll just say printf d dot get letter at I. And we'll say finding that letter. Oh, interesting. You know what? I only... I didn't account for the normal condition here. I only counted for going over and going under. I didn't count for just the regular. So we just say else if, and then we just say else current position equals current position plus steps. That's a very silly way to make a mistake. And I don't care about this printf anymore. There we go, there's our 13. So this other one, ring godding with key GD. Let's see what we got. 4, that's correct. So what we'll do is we'll just copy in everything. We'll find all the instances of FMT and get rid of those. Get rid of this over here. Get rid of the package definition. Copy this over. Paste it in and see what happens. Accepted. Fantastic. Let's submit it. So we'll see if they hit us with something messed up. Yeah, there we go. Output 20, expected 19. Only 55 out of 303 test cases passed. So this is going to be a dynamic programming. Love to see it. So NYNGL is the ring, and the key is YYYNNNNLLLGG. I got an extra one. So N, it goes forward 4. Y, it should go back 1. G, it should go back like 3. And then L, it should go back another 4. Why did this fail me? N, Y, N, G, L. I was not expecting it to fail this quickly. Well, let's throw it in there. Let's undo getting rid of these things. So it's the ring is NYNGL, and the key is YYYNNNNNNLLLGGG. And then we'll import flumped again, run it, and we did get 20. Need a new line there. Rotating 1 step to get letter Y. Rotating 0 steps to get letter Y. Rotating 0 steps to get letter Y. Y, 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 N, 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 L, 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 G, G, G. So Y, Y, Y. That makes sense. 1 to get to Y. 0, 0 to get to Y, and then 1 to get to N. Bunch of zeros to get to N, and then we go 2 more to get to L. Well, that doesn't make any sense. 1, 2. Should go negative. Well, I guess 1, 2. You go from N to L, it is 2 steps. And then you go -1 step to get to G, and then you stay there. But we're going an extra step. Because if we had gone from N to, let's see, if we had gone from Y to N going forward, then it would, no, if we go from Y to N going backwards, then to go to L, it would be -1 step instead of +2. Interesting. So what we need to do is we need to account for if there's multiple of the same letters going to either one of those letters each time in the ring. So the comment in the bottom talking about how it was a dynamic programming problem, I think was right. So what we need to do is each time there's multiple of the same letter, we need to check to see if there's a faster solution by going to the other direction. So it's not every time. Because if it's contiguous, if it's 2 letters that are the same right next to each other, no matter what, you kind of have to, it's not gonna make a difference going outside of that. Trying to think of best way to model this. But now I understand why this is a hard problem instead of an easy one, because this shouldn't be that difficult otherwise if it wasn't for cases like this. But they did say the least. So where's the, I don't want this. Solutions, I don't want this. I want, where's the problem? How do I go back to the problem? I don't want all submissions. Description, that's what I want. Also, is this guy given the thing? Your current position on right is not equal to your current position. And look for the closest left-right positions and jump on those, paying the distance price. The minimum of 2 is your best choice for your current position, yeah. Yeah, in short, this problem would be medium easier if there were no duplicates on the ring, because the duplicates in the problem is hard. Yeah, that's exactly what I'm saying. I made sure not to look at that solution, so I'm not like tainting my mind. Got to figure it out on my own, right? So to solve duplicates on the ring is going to be much more difficult, I guess. So I guess I feel like there's a better solution for not just brute forcing it, but we could just try going to each position of the duplicate on the ring and solving everything out that way, and then counting out the turns, which might be annoying. That's going to fill up our memory and take a lot of time. So yeah, let's do that. Let's do a type possible. Well, here, let's. So we have steps taken, which we're not even using. The song kind of slaps. It's not like a real in-your-face slapper, but it kind of slaps. Also, yeah. This is a tough problem. Now that I'm, now that I realize the issue with it. I mean, I kind of suspected this would be the problem. But yeah. So let's see what we can do. So how do we make it choose this in instead of this in? I guess we can just look ahead once or twice. But I bet there's probably going to be a couple of problems in the inside of the. Oh, that's not what I wanted. Submissions. How do I bring this out? Okay. So I'm guessing inside of the however many 303 test cases, they're probably going to put something that makes it so if you look ahead one or two, it doesn't work. I think I actually have to do dynamic programming here. And then just have a bunch of possible solutions and then go from there. So it's only ones where you could go left or right, because each time it's one where you could go, it's only ones where you can get to the same letter from the left or from the right, because if it's one where you can get to the same letter, so here's what we'll do. We'll ring contents, and then we'll have maybe we make an array of strings for problem letters, and then if we're searching for a problem letter, we kind of split up and figure it out from each direction anytime we do a problem letter. So I think we're gonna have to shove this inside of our If we get to a problem letter, what we need to do is we need to separate out into two until they find themselves on the same non-problem letter, and then whichever one is the lowest, we continue with that on. That way the memory won't go crazy. So we just have a pre-processing step to figure out what the problem letters are going to be. So then we just say for underscore comma k colon equals range key How do we check for duplicates? We'll check for duplicates by sorting it. So we'll say, let's see, sort Golang. Is there a sort dot string or a sort dot rune? Sort runes Golang. I guess we can make it bytes and sort those. Not use runes in 32 as int. Sort letters of a string Golang. Oh, this is a little gross. No, I suppose this looks like what you have to do. So we'll just do one of these real quick. We'll just yoink all this code straight from Stack Overflow. It looks like it should solve our problem. So then we say sort string, returns a string, import sort, of course. So we'll just call sort string on the string. Sort string key K2 colon equals. Is there a copy function? Yeah. How do I copy a string? Destination source. K2 string, copy K2 key. This is not the way to do this, but whatever, this will probably be fine. Oh, I don't want this at all. What am I doing? This is what I want to run. So I said K2, and then sort string. What did I call it? Sort string? There we go. And then we'll just say for underscore comma. So we'll say I colon equals range K2 if I is greater than len K2, we will break greater than equal, else if I is equal to I plus 1 if I is equal to I plus 1, then what we'll do is we'll say problem children plus equals 1. And then we'll say, not plus equals 1, problem children equals append problem children, comma, K2 at I. I'll say var problem children equals slice of rune. String. String. Man, this is getting nasty. Oh. What are we saying? Result of problem children equals append problem children string. Oh, it's not used. I see. So problem children problem children. So what we need to do is when we're finding a letter, if there's two instances of the same letter, which we've now stored in this problem children thing, what we need to do is go to both of them, determine, we need to go to both instances of the letter. Oh, but if there's multiple, there could be 3, there could be any number of the same letter on the same decoder ring. I don't like that. But we need to go to all instances of it and then run the same algorithm across all instances of it. And then check to see if, when you still run the algorithm, wait until you get to a non-problem child that, there's not multiple instances of it on the ring, and then get rid of all the losers when you do that. Whichever ones, whenever you get back to the same letter, get rid of all the ones that aren't the lowest number, or just get rid of all of them. You wanna. What do I want to say? It's like we'll put into a state called a quantum decoder ring, which can contain any number of decoder rings. So what we'll do is we'll say we'll do a new type quantum ring struct, which will contain a slice of decoder rings. And then we have to re-implement basically this entire thing for a decoder ring. So what we'll do is we'll switch out. We'll do a func new quantum ring. Func new quantum ring. And then it will take in the ring contents, which is a string, a problem children, which is a slice of string, and that'll be it. Ring contents, because outside of the quantum ring we are looking for the stuff. And inside the decoder ring, we're not going to want to do our counting outside of the thing. So what we'll do is let's see. D dot steps taken plus equals ABS steps plus 1. So now each ring will be in charge of keeping track of its own steps, which means that we won't need to be counting the steps up here. Our home, liberty, managed democracy, but freedom does not come free. You're a white guy, he likes beer. Who, our home. What are you on about? Chat, you're being very silly. I'm trying to advance the bounds of computer science. I'm trying to find this LeetCode code thing. Y'all are being very silly. Join the Helldivers today. Oh, this is a Helldivers thing. All right, I don't play video games, so you know. Ring contents, problem children is fine, except the decoder ring itself is no longer in charge of problem children. The quantum ring is in charge of the problem children. So we'll say problem children, slice of string. So then we'll get rid of problem children out of the decoder ring. So it only needs to know the ring contents, the current position, and the steps taken. The quantum ring needs to know the problem children and the rings. So then once we've discovered the problem children, we need to make a new quantum ring. R colon equals, we'll call it QR. QR colon equals new quantum ring. Then the ring contents will be, whatever this is, K. And the problem children will be problem children. What do I call that? K, it was key. Oh, I don't want key, I want the ring. Yeah. Excuse me. Not K, I want ring. Ring. Then down here, we will no longer take care of the total steps, so we'll get that at the end. And then we'll get rid of that. So for range K key, we'll say QR dot get find key K. And then we're not keeping track of the turns, and we won't even be keeping track of the rotations. And then what we'll do is we will return qr.min steps. So then we need to implement find key and min steps on QR. So QR will say func on receiver of QR pointer to quantum ring. So we'll say find key, or is it find letter? Should be find letter, probably. And this will take in a string, S, will be K for the key for the letter, L. This will be a string. And then we'll say is slices.contains. Is that a thing yet? Slice contains, yeah. Slices dot contains. If slices dot contains let's see, is that going in? Is that in the standard library yet, or do I have to like go get that slices package? Yeah, slices. Since 1.22. Slices. If slices dot contains, and what is this? Try slices dot contains. Oh, capital C. So I want the it reports whether V is present in S. So S followed by V. So slices dot contains in QR dot problem children, and then let's see. If it's a problem child, so if L is in problem children, so we'll say if the problem children contains the letter L, then what we will do is we will operate one way, and then otherwise we will run the collapse function. We'll collapse the wave state down to the single most effective ring from their quantum ring. So say QR dot collapse. So then we'll say func QR pointer to quantum ring collapse. And then we'll just say for underscore comma r colon equals range QR dot rings. Let's see, true ring. Our true ring is a decoder ring. Fantastic. If r dot steps, let's see, if true ring equals nil, then what we do is we say true ring equals r, and we go on with our lives. I'll make it a pointer to decoder ring. Why not? What's the address of R? Where's the address of? There we go. Else if R dot steps taken is less than true ring dot steps taken, then we'll say true ring equals ampersand R, and then we'll say QR dot rings equals slice of decoder ring that is filled with only the dereferenced version of R. And of course, oh, dereferenced version of the true ring, excuse me. So then what we'll do is so let's see, if it's not a problem child, we'll QR.collapse, and then we'll say QR dot let's see, ring func colon equals quantum find, and And this one we'll say, we'll collapse it and we'll say, not ring func, we'll call it find func. Find func, find func. So this is gonna be fun. I don't even want ring. I want letter. Func that takes in a string. So for a quantum ring, if we run quantum find, that means create a new universe in which there's a new ring for every direction to get to a different copy of the letter. And then our regular find will just find the letter and then add it to the one ring. But the quantum find has to do it for every ring. And check it out. But I think I'm missing something. So what we want to do is actually just we're just going to run qr.quantumFind here. And here we're just going to run qr.regularFind here. And we won't use this function. So let's define regular find real quick. Func on quantum ring takes in a pointer to quantum ring. We'll say regular find L string. Oh, I see where I went wrong. It's not if we're looking for a slice is a problem child. Oh, what am I doing? I was writing this wrong. I'm dumb. So if we're trying to find a letter and it is a problem child, then that means we need to quantum find. So we need to go to both problem children and then create a universe for each one of them. If the letter is not a problem child, let's see. If the letter is not a problem child, then what we need to do is we need to find it and we need to quantum find it. We need to find it in each one and then try to collapse it back. So what we'll do is we collapse after we regular find. And that will get our state right. So regular find will be for underscore comma ring colon equals range qr dot rings. Then what we'll do is we do ring dot get find letter L. Let me check ring.find letter real quick. So this thing just returns the letter, but we don't want to do that. We want to say find letter. Wait, no. Get letter. Okay. So I just need to put in quantum find. Func QR pointer to quantum ring quantum find L string. Then we'll say new rings colon equals, let's say 4 underscore comma ring colon equals range QR dot rings. We will have some new rings, and the new rings will be ring dot quantum search for that letter. And then we will say quantum ring dot rings equals append quantum ring dot rings comma new rings. So then we need to implement quantum search on the ring. So we already have a find letter function. Man, this is truly a LeetCode hard problem. So we'll say func d pointer to decoder ring. You know what? I think we need to know how many. We don't need to see if slices contains problem children. We need to know how many problem children are. So this will be a map of string to int. So then not slices.contains, but we'll say if problem number of problem children equals problem children of L, and then we'll say if number of problem children is greater than 0, then we'll quantum find it with that number. And then quantum find will take in L, the string, and the number of problem children, which is going to be an int. Oh, undeclared. Oops. Colon equals, there we go. So then quantum search will take in L and number of problem children. And then we need to implement quantum find. So we need to get this problem children calculation fixed to work with the new type. So find rotate steps. So not problem children equals append. We'll say problem children at index problem children at index k2 at I equals plus equals 1. And of course, problem children should be a map of string to int. And we need to declare it, and instantiate one. And of course, new quantum ring needs to take in a map of string to int. So we fix that. So then let's see. So we'll say if problem, let's see. Underscore comma exists, colon equals, problem children at that index. And then we'll say if not exists, problem children at k2 of at index I equals 2, which means that there's 2 of that letter. And then else, we don't really need the else, we'll say problem children at k2 of I equals plus equals 1. And why is this mad at me? Cannot use value of type byte as map in index. Okay, sorry. String, not a byte. My apologies. Oops. String. String. Close that off. There we go. Oh. What am I doing? There we go. No quantum search, imported, not used, fine. So now we need to do ring quantum search. We are getting so close. So we'll say func d pointer to decoder ring quantum search, and this will take in letter, which is a string, and then taking a letter string as well as a number int. So this is the number of that letter we need to find, as well as the letter we're finding. So we need to call get letter or find letter. All right, so find letter searches forward and backward, and then returns the number. Find letter calls get letter, which does everything in a temporary letter. So then we'll make another one called get letter with starting point. Func d pointer to decoder ring get letter with starting point, and then it takes in no, we want to find letter with starting point. think we need to rename this to select letter. Oh. Well, who's mad at me? We'll just finish that thing here real quick. Quantum search. Oh, is this not right? Too many values. Oh. And this will return a slice of decoder rings. Those are pointed to decoder rings. And then this will just be pointers. And we have more problems. Cannot use new rings. Well, quantum search returns a slice of pointers. What's wrong with that? And qr.rings, slice of pointers, slice of pointers. Cannot use slice of pointers as... Oh. ... Make this slice of pointers, slice of pointers, the address of, code action, redundant type. All right. Which is the type? This is the redundant type. All right, and this could be smaller. Great. This truly is a hard LeetCode problem. I'm not having fun. And I forgot what I was doing. Oh, I was just going to rename something. So we will rename the find letter to select letter. And then, where am I locking it in? So we're counting in, well, all right. We'll rename this to regular select. Regular capital S select. No, we're not using this return value, are we? Oops, I don't mean to do that. So in rotate step. Okay, so we are adding that. But we're not using the we're not using the return value at all. Right, yep. So we're selecting a letter, and then instead of get letter, we'll rename this to find letter. Find letter. Oops. Oh. Find letter. Okay. So what we need to do is quantum search. And it's actually quantum select. Then what we need to do is we need to find the first one, and then we need to find the first letter that has it. We need to find the first ring, find that letter, and then, sorry, for every ring, we need to find every instance of that letter at all the different rotations, lock those in, and then return those decoder rings. If that makes sense. So how do we do that? So I guess we just need to find the first one and then exclude that one and then keep going after that. And then return it after finding each of them. So then we'll say d dot, so we'll say for for what? We'll define exclusions. Exclusions colon equals slice of int, which will just be indexes. Exclusions are indexes in the decoder ring string. And then, so we'll define the exclusions, and then we'll just say, and then we'll find a returned rings. Returned rings colon equals slice of pointer to decoder ring. And these won't be return rings, those will be extra rings. Extra rings. So what we'll do is we will let's see. I guess what we can do is we can just search through and find all of them on one ring and then return the second and third worst one, or you know, we'll find all of the options, the smallest option to get to every instance of the letter. Once we've done that, man, this is really annoying and complicated. Why did I do this for a living? I mean, I don't do leak code problems for a living, of course, but man, this is silly and difficult. So we're not gonna do exclusions. We're gonna just say for, let's see, found for so we need to find the first one, and then we need to find additional ones. So the first one is not too hard, except for the fact that we don't want to lock it in yet. I guess in the first one we can lock it in, but we don't want to go from that point to the others. So we'll say temp ring colon equals decoder ring. We will fill that in. Ring contents will be d dot ring contents. Current position is going to be d dot current position. Steps taken is going to be d dot steps taken. And then the direction, the extra rings will just be number minus one of them. Let's make it real easy. Yeah. So we'll say for x equals number minus one, x minus minus, x is greater than 0. Oh, it's really mad at me. Oh, x colon equals that. Let's... So what we will do is actually we will select the letter on the first one. This is a weird song. You know what? I should have made this return the int. So what we'll do is we'll just continue the search from the last one we got to. This is a tough one, but I think this will work. So we'll do another select letter. Select letter starting point, and then this will take in a starting point int. And then what we'll do is we'll just call select letter d dot select letter starting point with the target, and then the starting point is a 0. And we'll just return that. So that's really easy. So we haven't actually increased our complexity, really. So instead of doing an I colon equals range ring contents, we'll say I colon equals starting point. I is less than len, say ABS, I is less than length of ring contents. And then we'll say I plus plus. Except what we'll do is we'll just say mult colon equals if I is less than 0, else var mult int. If I is less than 0, mult equals -1, else mult equals 1, I equals, sorry, starting point. Starting point is less than 0, mult equals -1, otherwise mult equals 1, and then we start with ABS starting point. No, we don't. Ring contents. I times, let's see, equals mult. What I'm trying to do here is really silly, and I'm kind of half code golfing and half just being dumb. This is not smart. You know what? Yeah, this is dumb. I'm just gonna get rid of all this until we're back to where we were before. I colon equals range d.ring content. So we'll say if starting point is less than 0, we will do one thing, else we will do another thing. And we'll say I colon equals starting point I is less than len d dot ring contents I plus plus. So then we can delete that. Add one of those. So this is for if the starting point is not less than 0. And then otherwise we will do the same thing up here. So I is going to be starting point. I is what I'm trying to do is if I'm starting at the left, I want it to just move on to the next one and not research the first one. And then I only want it to, I want to skip the one that's been missed, or the one that's already been found. Man. They really put in one little thing to make this whole thing very complex and annoying. I don't want to let this thing defeat me. I gotta finish this. We're sorry, but your scheduled viewer time service has run out. Thank you for using our service. Goodbye. All right, Irish. I'll see you. Anyway, now that Irish Red Ales is gone, let's just actually just solve this immediately and get first place in the world. Literally not a problem. Easy peasy. So instead of starting point, we'll just do found letters, or no. What time is it? It is 10:17. Maybe I do stop. Maybe I just solve this on my own time. It's not about you guys watching, and I don't even think you guys are watching. I see 5 viewers, but I've only seen 2 people, and one of them just left. You guys bots? People real? Am I just coding for no one? Is that what's happening? I don't know how any of this works. 4 viewers. You see, now someone caught me. If someone knew I recognized, one of you was an advanced bot. I don't know. I think it's time to leave. So on that note, it's been real. It's been fun. I can't say it's been real fun, but you know, nearly solved the simple solution that wasn't actually the solution to the sleek code. So that's all fun and fine and dandy. Otherwise, I'll just catch you guys on the flip. I'll be back on Monday with I think Monday is the interview with the Zed people. Otherwise, I think that's about